On a sunny day at the beach, the sand can become so hot under the sun that it burns our feet, but the ocean remains relatively cool. And hopefully we all know that, right? Because if your feet are burning on the sand, what do? You probably run into the ocean to cool them down. Or maybe you run the other way, but we all know the ocean will cool us down if we get to it, right? What does this suggest about the specific heat of sand versus water? Well, I would first venture to say that I think the heat capacity of the water is much larger because they're both getting heated by the sun. There's a heat process occurring of the sun transferring thermal energy both into the water and the sand. But the water remains relatively cool, which means its temperature isn't really changing very much. One way to think about heat capacity is it's kind of like inertia, but in a thermal kind of way. The more heat capacity something has, the more it resists a temperature change. So that's why I think the water, since it's very resistant to temperature changing, must have a higher heat capacity. If we want to translate that into specific heat, though, so if we're talking about an equal mass of sand versus an equal mass of water, then this would say that the specific heat of water is quite a bit larger than that of sand. Although the way this question is phrased, it says, what does this suggest about the specific heat of sand versus water? I would say the specific heat of sand is much lower, and therefore it reaches a high temperature for an equal amount of mass far more easily. So let's see what the slide says. It says the specific heat of sand is far lower than that of water. That's pretty darn close to what I just said.